the derivative. So the derivative with respect to time of velocity is equal to acceleration. Therefore, I take a look at this. The power is 1. Throw the 1 out in front. 1 gives me negative 10. All right? And then this is t to the 0. 0 makes that 0, so plus 0. So this is negative 10 meters per second squared. So far, so good? Now it says, what's acceleration 3 seconds into the flight? Same thing, right? Because it's not changing. So my acceleration at 3 seconds, notice the notation, is negative 10 meters per second squared. That's B. C. I want to find what my displacement is. So my displacement is going to be integral velocity with respect to time. The integral with velocity with respect to time is going to give me displacement. And in this case, I'm going to do what to my powers? Raise up my powers by 1, divide by the power I get. So I'm going to go t to the second, negative 10 divided by 2, plus 45 t to the first divided by 1, but I'm missing something. What am I missing? This thing starts 20 meters above the ground. This is displacement from the beginning to the end, but I want it relative to the ground. So what am I going to do? We're going to add 20 because it's 20 plus, right? Yes. Whatever this number gives me, it's going to be 20 above that, right? So I'm going to add 20. Now here's something interesting. When you take an integral, people who haven't had calculus, listen carefully. Whenever I take an integral, Miss Lasagna, you hear me? This one's going to trip you. Whenever I take an integral, I have to add the initial condition. Okay? Whenever I take an integral, I'm going to add the initial condition. So since I'm finding displacement, I'm going to add the initial displacement. Okay? Now, why that is because if I take the derivative, what's going to happen to this 10? So what's going to happen to this 20? It's going to disappear, right? T to the 0, it becomes 0, it goes away. Then if I integrate, it's gone. So anytime you take an integral, you've got to remember to put the initial condition back in. Okay? Does that make sense? Okay, so then for D, what is my displacement at time equals 5? Oops, trying to do this in my head, it's going to be a little tricky. Negative 125, 225, 100, 120? Good? Does that make sense? Can we do that? Okay, so remember you do it, hey, take an integral, you have to tack on the initial condition because unfortunately when you go this way, it disappears. So coming back the other way, we have to put it back in. Okay, all right. Have that.